Hello, Y12s. At the moment, I am busy with question 2 in the 2021 paper. So, again, it's probability trees. Let's read through the question. The use of plant-based milks in New Zealand has become much more popular in more recent years. Cafes also now offer their customers a number of alternative milk options such as soy, almond, or coconut. Jungwoo owns a cafe and has collected data on his coffee sales over the last few weeks to find out how much he should stock alternative milk products. I'll apologize if you hear any noise. My husband's making dinner. Um, Otherwise, I'm just going to keep going. Or if you hear dogs playing, that's what it is. Okay, so it says 40% of his coffee sales were to younger customers. 1/4 of younger customers requested an alternative milk type. 80% of older customers ordered a coffee with cow's milk. Of the younger customers who ordered a coffee with alternative milk, 15% ordered soy milk. Half of the older customers who ordered a coffee with alternative milk ordered soy milk. Okay, so let's get drawing. So we've got younger customers, we've got older customers. So they haven't started us, they've given us nothing. So we've got to start it off. So I'm going to have younger customers, and then I'm going to have older customers. And they say 40% of his sales were to younger customers. So this is going to be 40%, which I'm putting into a decimal, 0.4. Okay, immediately I know this is going to be 0.6 because this has to add up to 1. Okay, that's the first one, check. Next one. 1/4 of younger customers, so 1/4 of these customers, requested an alternative milk. So alternative, and that was 1/4, which is 0.25. Okay, I'm not entirely sure what that is just yet. Let's read on. 80% of older customers ordered coffee with cow's milk. Okay, so that's the other option. So it's either going to be alternative or cow. And he's going to have here for older, alternative, or cow. Okay. And they said here that 80% of older customers ordered a coffee with cow's milk. 0.8. Okay, so I can already work it out that this is going to be 0.2 because that has to add up to 1. This is going to be 0.75 because that has to add up to 1. Okay, now it says of the younger customers who ordered alternative milk, 15% ordered soy. Okay. Then it says half of the older customers who ordered a coffee with alternative milk, so half ordered soy. Okay, and that's all they give us. We can't do anything else. Okay, that's it. Now let's have a look at question I. Find the probability. Let me just quickly scroll down here for you. Okay, there we go. Okay. Find the probability that a customer in this cafe is younger and orders a coffee with cow's milk. So we're worried about a customer that is younger and orders cow's milk. So we're going to go 0.4 multiplied by 0.75. Okay, and when you pop this into your calculator, you should be getting, multiplied by 0.75, 0.3. Okay, check. Nice. Next one. Find the probability that a randomly chosen customer orders coffee with soy milk. So any customer, they're not specifying young or old, just anyone that uses soy. So we're going to be using soy there and there. So to work out this probability, we know it's going to be that times that times that, and we're going to add on that times that times that. So let's write that down. 0.4 times 0.25 times 0.15 plus 0.6 times 0.2 times 0.5. Okay, so I've just gone and multiplied along these branches. I've done that, times that, and I've added on that times that times that. Okay, and if we pop it into our calculators, we're going to have 0.4 times 0.25 times 0.15. That gives us 0.015. Then we've got 0.6 times 0.2 times 0.5. That's going to give us 0.06. And if we add those together, you should get 0.075. Okay, and if I have a look at the schedule, this question, II is worth a merit. If you got one of these correct, you'd have gotten an achieved. Final answer is a merit, and this is just worth an achieved. Okay, let's look at question II, which is, I quite like this question. Okay, so they're asking, out of the customers who request an alternative milk, what percentage orders a coffee with soy milk? So out of customers, that's generally your hint to tell you that's going to be the denominator. So like if you think about a percentage, I got 70 out of 100. My 100 is my denominator, my 70 is my numerator. So out of the customers who request an alternative milk, so that'll be the denominator, what percentage orders a coffee with soy milk? That'll be the numerator, and we're going to multiply that by 100 to give us a percentage. So let's first worry about our denominator. Let's do our alternative milk. So the probability of someone who requests alternative milk is going to be, let's have a look back here. Where are we doing alternative milk? So we are doing alternative milk over here and over here. So we're going to do that, multiply by that, multiply by that. We're going to add those together. So it is going to be 0.4 times 0.25 plus 0.6 times 0.2. And if we pop that into our calculators, we're going to have 0.4 times 0.25. This is going to give you 0.1. Then we're going to have 0.6 times 0.2, which should give you 0.12. If you add those together, we are going to get 0.22. Okay, so you've just worked out the probability of alternative milk. That's going to be our denominator. Okay. Now, whenever they're asking you to do a percentage of comparing one thing to the other one, we're obviously going to have a little fraction going on. Okay, so we know that this is our denominator, so I'm just going to put a little d there for denominator. Now, what percentage order a coffee with soy milk? We actually worked this out in question II over here. We worked it out here. Find the probability that a randomly chosen customer orders coffee with soy milk. We already worked that out. So what we're going to do is we are going to do our little fraction, which is going to be 0.075 divided by 0.22. Okay, and we're going to multiply that by 100. So let's do that. Let's do 0.075 divided by 0.22 multiplied by 100. It's going to give me 34.0909. And because it's a percentage, we do 2 decimal points. 09%. Okay, there we go. That's I. So that's the percentage when we have to compare alternative to soy. Okay, let's move on. We've got a nice little excellence question over here. I'm going to go to a new page for this. And it is connected. So you'll see it's II. All of these are connected. So we're most likely going to be using some information from here too to help us draw this tree. So let me go to a new page and start off with this question. Where am I? There we go. Okay. Now, The probability that a randomly selected customer ordered an almond milk coffee is 0.066. Of those who requested alternative milks, there were equal proportions of those ordering almond milk in each age range, while the rest of the customers ordered coffee with coconut milk. How many times more likely? Ooh, we know that that is relative risk. As soon as they're asking, is this more likely than this, or how many times less likely is this, we know that we're going to end up doing some sort of relative risk. We've got a fraction. So how many times more likely is it for a customer to order a coffee with cow's milk than coconut milk? Okay, so let's go with our drawing. So pretty much the only thing that we've added, because if I have to look at our previous drawing, we had young, old, alternative cow, and we had soy. But right now they're adding on almond and coconut. Okay, so if I have to quickly, I'm wondering if I can't actually just add it on here. This actually might make my life a little bit easier than having to redraw it all over again. But they've said, so they're saying the probability that a randomly selected customer ordered an almond milk coffee. Okay, so we don't have anything yet here for almond. So we're going to need to have some sort of almond. Okay, and then they were also talking about coconut milk. Coconut milk. Okay, now let me just have a little look here, because these numbers might change. Let's just read again. So, of those who requested alternative milks, there were equal proportions of those ordering almond milk in each age range. So they're saying that these are the same. They're not telling us what it is, so guess what we're going to put? We're going to put an X. While the rest of the customers ordered a coffee with coconut milk. Okay, so let's just double check that I've got everything I need. Yeah, perfect. Now, the only thing that's missing is that is missing, and that is missing. And we know that that has to add up to 1, that has to add up to 1. So we know that this is going to be 1 minus 0.15 minus x. Now, to be fair, we could actually simplify the 1 minus 0.15 is going to be 0.85. So we 0.85 minus x. That's this for coconut milk. Then this one is going to be 0.5 minus x, because 1 minus 0.5 minus x is going to be 0.5 minus x. Okay. So boom, we've just worked that out nice and easy. Okay, that's simple. Now let's just double check we've done everything we need. So equal proportions of almond, amazing. So they're actually talking about somebody ordering almond. The probability that a randomly selected customer ordered an almond coffee is 0.66. Remember, that's also one of the hints where they give you a probability of something. Let me use yellow so that we're not getting confused. So they want to know, well, they're telling us that the probability of this plus the probability of this has to give us 0.066. Okay, so the probability of someone ordering an almond is going to be 0.066. Okay, now they want us to figure out how many times more likely it is that a customer is going to order a coffee with cow's milk than coconut milk. So we're going to need to figure out the probability of cow's milk and then divide that by the probability of coconut. But now the issue is, you see how we've got a letter here. So we can't work out this probability of coconut without figuring out what our x is. So that's what we're going to do now. And we are going to use our equation solver on our calculators to do this. But let's first set up an equation. Okay. What do we know? We know that the probability that a randomly selected customer ordered an almond milk coffee is 0.66. So we know that this probability plus this probability equals something. So let's first do this probability. What are we going to do? We're going to go 0.4 multiplied by 0.25 multiplied by x. Okay? That plus whatever this probability is, which is going to be, let's go 0.6 times 0.2 times x is going to give us, what do these two add up again? Oh, they told us 0.066. Okay, now I'm going to grab my equation calculator so you can have a look at how I'm going to do this. Share. Okay. It's a little bit small, but I'm going to just quickly get rid of that screen. There we go, so you can see it. Okay, now, if I go to my menu, down to equation, I want the solver, which is F3. I have to delete what I did previously, which is going to be F2. Yes, delete. Now, let's get going. So, I'm just going to put in what I've got here. So, we've got 0.4 times 0.25 times, and I've got an x in here. Again, you don't have to use x. I'm just going to use x because I'm just trying to keep it the same. Close brackets. So that plus 0.6 times 0.2 times x, so alpha x, close brackets. This has to equal 0.66. Don't click that button. We have to use the equal sign that is here, which is shift. Okay, we got our equals, and what is this equal to? 0.066. Okay, now if I click on equals the first time, remember it's going to look a little strange. Click on it again. There's my answer. So x equals 0.3. Okay, fantastic. Now, I'm going to get rid of this because we don't need it just yet. Let's go back to that and get rid of our calculator because we do not need it just now. Okay, perfect. Now, amazing. We've worked out what x is. Now, what do they want us to compare? How many times more likely is it for a customer to order coffee with cow's milk? Okay, so we're interested in cow's milk. Where's my cow's milk here? So I'm going to do that times that plus that times that. Okay, it's my probability of cow's milk. They want us to compare that to coconut milk. Okay, so let's first do the cow's milk. Okay, so probability of cow's milk, okay, is going to be 0.4 multiplied by 0.75. Okay, just that times that. And we're adding on 0.6 times 0.8. Okay, so there is my probability for cow's milk. And if I do that, it's going to be 0.4 times 0.75. So this is going to be 0.3 plus 0.6 times 0.8 is going to be 0.48. And if we add that to the 0.3, we're going to get 0.78. Perfect. Okay, so that's our probability of cow's milk. Done. Okay, now remember, because they say cow's milk first, this is going to be the first part of our fraction. This is our numerator. Okay, now let's work on our denominator, which is going to be the probability of coconut milk. So, let's work this out. Coconut milk is going to be this over here, okay, which is going to be that times that. Oh, sorry, alternative, that times that. Okay, so we're working with that times that times that, okay, which is going to be that. Where else are we doing coconut milk? Over here. Okay, so we're doing this times this times that. Okay, now, just to make my life easier, I just want to quickly work out what this is separately because I don't want to have this long equation. You can, but this is just how I want to do it. So I first want to quickly work out what is that. What is coconut here? So we worked out x was 0.3. So if I can just work out what this probability is, it is going to be 0.85 minus 0.3. And that is going to give me 0.55. Okay, so I've just worked out this number over here. Okay. I'm going to do the same over here. So it's going to be 0.5 minus, what is x? Oh, I worked it out. X is 0.3. And that's going to give me 0.2. So 0.5 minus 0.2 is going to give me, 0.3 is going to give me 0.2. So I've just worked out that answer over there. Okay. Now it's going to be a little bit easier for me to put this all together. So let's first do the top coconut. So it is going to be 0.4 times 0.25 times this, which is now 0.55. So let me write that down. So we've got 0.4 times 0.25 times 0.55 plus, so we've just worked out that one. Check. Now I need to work out the next one, which is this one over here. It's going to be 0.6 multiplied 0.2 multiplied by that, which is now 0.2. Okay, so let's do that. We're going to have 0.6 multiplied by 0.2 multiplied by 0.2. Okay, and now if we do that first bracket, 0.4 times 0.25 times 0.55, we're going to get 0.055. We've got 0.6 times 0.2 times 0.2. This is going to give us 0.024. And if I add that to 0.055, we should be getting 0.079. Now, they're asking us to compare, or how many times more likely is this than this. So cow's milk is numerator. So 0.78 divided by, what is our denominator going to be? Let me double check that I've done my calculations correctly. So it is very possible that I've made a mistake. IV, here we are. Yep, 0.78 divided by 0.079. We're on the right track. And if we pop this into a calculator, divided by 0.079, we're going to get an answer of 9.8734. Okay, so what that tells us is this top number, which is cow's milk, okay, a client or a customer is 9.87 times more likely to order cow's milk than coconut milk. Okay? So remember, this number on top is cow's milk. I can quickly highlight it to make your life easier. Cow's milk, we work that out here. Okay? And then we've got our coconut milk, which is our denominator, which we worked on over here. So basically that means that this numerator on top is 9.87 times more likely. So a customer is 9.87 times more likely. Sorry, my husband's packing dishes away. That's why it's so loud. Times more likely to What are we talking about? Order a coffee. There we go. Order a coffee with cow's milk than coconut milk. Done. Okay, now, just for argument's sake, if this number was 1, okay, or like 0.99, okay, which is really close to 1, it means that this is the same likelihood as this, okay? They're likely. If this number was like a 0.5, it means that this is less likely than this by 0.5, which is by half, okay? So in this instance, this is 9.87, which means 9.8 times more likely. Okay, thanks so much. Do I have another one? I do. I've got another one. I've got question B, which is a completely separate question. So we can do B quickly. Baby, how much longer for food? 5-10 minutes. That's enough time. Perfect. I am going to do question B as well, which is over here. Okay, now we've got something given to us here already. So let me quickly draw that. So we've got long black over here, long black, 0.3. Then we've got flat white. Then we've got both available. We've got 1 available. Then we've got almond, coconut, almond, coconut. And this is 0.4. So we know, like, even I don't even have to read the context. I can already tell that. Let me just do that a little bit. Oops, sorry. There we go. I can already tell that this, because that is 0.3, it's going to be 0.7. That is 0.4. I know that is going to be 0.6. Okay, I don't know this just yet. Okay, let's have a read through. So, Kathy prefers to drink a flat white coffee with milk, but is allergic to cow's milk and dislikes soya milk. Well, I guess that makes sense. Are you laughing? I guess that's why soy milk isn't included here. When she goes to the cafe for the first time, if it does not have an alternative milk available, she orders a long black with no milk. Okay? She finds this happens about 30% of the time. Okay, that's where that 0.3 comes from. Perfect. Next paragraph. She has found that out of cafes that offer alternative milks, about 40% have both almond and coconut milk available. Great. If the cafe has both almond and coconut milk available, she flips a coin and chooses either one randomly. Okay. So in my mind, if you flip a coin, that's 50-50. That's only if both are available, though. She said if the cafe has both almond and coconut milk available, so both available, she flips a coin. Now, next sentence. Kathy has also noticed that if a cafe has only one soy alternative milk available, it is twice as likely to be almond as coconut. So, twice as likely would be almond as coconut. So they're saying it's twice as likely it'll be almond than coconut. Now, we know that this has to add up to 1. So, if we go 2x plus x has to give us 1, if you really don't know how to do this, just put it into your equation solver. But basically all this is it's 2x's plus another x gives us 3x. Get rid of the 3. So x is equal to 1/3. So if this is 1/3, it means this is going to be 2/3. Done. Okay. So interesting. Ooh, I'm getting food. If you've got X on both of these, you're able to work it out. No, you can give it. You can look at my dinner. That's okay, my lovey. Thank you very much. Okay. So, oh, that smells actually so yummy. Damn. Did you put feta on, my love? Okay. So, the question is, I'm getting distracted here by my food. My question is, overall, is it more likely for Kathy to have a long black, an almond milk fat white, or a coconut milk fat white? Okay. So let's just work out the probabilities of all of them and see which one's highest, because that would mean this one's more likely to happen. So we know that the probability of a long black is 0.3. That one's easy, right? Let's now work out the probability of almond. So where is almond? We are here. There is almond, there is almond. So that times that times that. And then that times that times that. So probability of almond is going to be 0.7 times 0.4 times 0.5 plus, because I have that there, I can't continue, plus, I'll continue in the next line, 0.7 times 0.6 times, we figured out that was 2/3. Perfect. Now let's pop that into our calculators. And let me clear. Okay. 0.6 times 0.7. So I worked out this little bracket is 0.28. This first bracket, let me work it out, is going to be 0.7 times 0.4 times 0.5. 0.14. If you add those together, we are going to get 0.42. Already, more likely she's going to have an almond compared to a long black. But now that's not all they're asking about. They're asking about coconut milk. So let's have a look at coconut milk, which is going to be this one over here. So it's going to be that, times that, times that, and that times that, times that. Okay? So let's do that. We have got, so the probability of coconutty, is going to be 0.7 times 0.4 times 0.5. Okay, plus this group over here, which is going to be 0.7 times 0.6 times 1/3. Now, times 0.6 times 0.7. So this is 0.14. And we could do 0.7 times 0.4 times 0.5. I got the same answer. 0.7. Let me just double check my other one. So it's 0.33 recurring times 0.7 times 0.6. Yep, same answer. Okay, so if I add those two together, we're going to have 0.28. So from this, whichever one's the highest number, she's more likely. So they're asking, is it more likely for Kathy to have a long black, an almond flat white, or a coconut flat white? So it is more likely for her to have a almond milk flat white. And these are the calculations to support it. So if I look at the schedule, all you would have to say is a sentence that says, Kathy is more likely to have a almond milk flat white than a coconut or long black. And you're good to go. That is worth a merit, not worth an excellence, worth a merit. If you found the probability of that or the probability of this, you would have gotten it achieved. And then to do both and have that statement of saying that Kathy is more likely to have a almond than a long black or a coconut. That would have gotten you your merit. So that is that. Hope that helps, and toodaloos.